Time to review for the Chapter 10 test. On your test, you need to be able to classify angles, triangles, and polygons. You need to be able to name angle pairs as vertical, adjacent, supplementary, or complementary. And you need to be able to find missing angle measures in either angle pairs, in triangles, or in polygons. Alright, so in this first example, we need to find the measure of angle 3. Okay, this M means measure of angle 3. So notice that these two angles come together to form a 90-degree corner. So if I know that these two together make 90 degrees, I can subtract what I see, and then I know angle 3 is going to be the remaining part of that 90 degrees, so it will be 40 degrees. What angle is supplementary to 65 degrees? This chapter, there's a lot of vocabulary. Supplementary, remember, means that it adds up to 180 degrees or a straight line. So I know that I start with 180 degrees. I know that there's two angles that add up to 65 degrees, or sorry, to 180. So one of them is 65. I'm going to take that one away and see what's left. So I have to borrow here. 115 degrees is left. And that's what angle would be supplementary because these two together make 180 degrees. Find the measure of angle A in the drawing below. So notice that these three angles together make a straight line. And all straight lines are 180 degrees. So if I take these two together and subtract them, because 70 and 15 together are 85, I get 95 degrees left. That's going to go here because I want all three of these angles to add up to 180. In the bottom it says state if the angle pairs are adjacent, which means next to, vertical, which means across from, complementary, which means they add up to 90 degrees, or supplementary, which means that they add up to 180 degrees. They could be more than one of these. It could be a combination of more than one. They could be none of these things. So angle M and angle N. Here's M, here's N. If I'm looking at those two, they are next to each other, so they are adjacent. I also notice that they form a straight line together, so they are also supplementary. Angle Q and angle M, those are across from each other, so we would call them vertical. They're both bigger than 90 degrees, so there's no way that they would be supplementary, and nothing's bigger than that, so it's just vertical. Angle R and angle M are next to each other, so they're adjacent. They also form a straight line together, so they are supplementary. And lastly, angle R and angle N. R and N. Those are across from each other, so they're vertical. It's possible that those could add up to 90 degrees, but you can't tell from this picture, so we're just going to leave it as vertical. Alright, it says find all the missing angle measures. So knowing that angles that are across from each other are vertical angles and that they are congruent, which means the same size, we can automatically say that this angle here is also 115 degrees. What else do we know? We know that the angles that come together to make this line are 180 degrees. So this angle and this angle together make 180 degrees. So I can take 180, subtract 115, and I am left with 65 degrees. 65 degrees would go here. Now there's two ways I could tell what goes here, and that's one, that these are vertical, so they're going to be the exact same. Or I could do that exact same math problem, take 180 minus this 115 to get my 65 degrees left. The bottom says label each acute, obtuse, right, straight, or reflex, so we're naming these angles. This first one, if you have a device that you can turn, you can, sorry about that, you can see that this first one's just a little bit bigger than 90 degrees, so we're going to call that obtuse. The second one's definitely less than 90 degrees, so it's acute. Third one, bigger than 90. Fourth one, exactly 90, so remember that's a right angle. And this one that's a straight line is a straight angle. Remember, reflex means that it's bigger then 90 degrees, and we're not even going to worry about that because you can't really tell if this is going this way or this way. So we're just going to ignore reflex angles. You don't need to worry about them for your test. All right, it says use this isosceles triangle to find the measure of angle A. Okay, so if we know that this is an isosceles triangle, we know that these are the same measure. So we know that this measure and this measure are the same, but I'm just looking at this and saying, okay, if that's the same, I could just flip this over and make it fit in here, couldn't I? And so there'd be triangles in here, so my 20 degrees would be the same as this, and so A is 20 degrees. What do you know about two of the angles in an isosceles triangle? Well, we just kind of said it. The two angles that come down to meet the line that's different in size are going to be equal or congruent. Find the missing angle measures. So we know that a triangle adds up to 180 degrees. If we know the measure of angle A is 105 degrees, the measure of angle B is 35 degrees, we know that whatever's left is going to make 180 when we add them all up. So we're going to take 180 and subtract 140 because that is 105 and 35 put together. And I'm left with 40 degrees. Oops, there's already a degree sign. Okay, here's another one. Same situation. It adds up to 180. I'm going to take away what I have. I have a 51 degree angle, and remember this symbol means 90 degrees. So when I put these two together, I have 141 degrees. And so I'm left with 39 degrees for angle W. And lastly, I have no picture, but I don't need a picture. All I need to know is that I have 180. Take away what I see here. Now, since that's 80, I like to just take that away and say, okay, now I'm down to 100. Take away my 33. Now I'm at 67 degrees. That goes there. Name the polygon, then determine the sum of the interior angles of each polygon. This is probably one of the harder things. Remember, you name a polygon by the number of sides. So let's first count the sides. There's 1, 2, 3, 4, 5, 6 sides. 6-sided shapes are called hexagons. This is definitely something you're going to want to memorize, all of the names for the shapes. This is an irregular hexagon because I noticed that this angle and this angle, they're different in size. This side and this side are different in size. To find the number of degrees, the sum of the interior angles, remember I'm going to find how many triangles make this up because I know that there are 180 degrees in a triangle. I can figure that out. So I'm going to start at one vertice and I'm going to go to all the other vertices, also known as corners, right? Definitely don't cross any of these so that you have just the smallest amount of triangles you can possibly make. And I see that I have 1, 2, 3, 4 triangles. Each triangle is 180 degrees, so I'm going to take that and multiply to find out how many degrees do I have altogether. And when I do that, I get 720 degrees. All right, the second one, it's a quadrilateral. I want to know the best name for that quadrilateral. And looking at this, it does not look like any of the sides are parallel. Well, I guess these two look parallel, but these do not. It looks close to a trapezoid, but I'm just going to call it a quadrilateral because there are no symbols to know that it's something better than that. Quadrilateral. Okay, sum of the interior angles, again, start at one side. Draw your lines to all the other corners. I have 2 triangles, 180 degrees in each one, for a total of 360 degrees. And what does it mean to use diagonals to decompose the polygon into triangles? Exactly what I did here. I'm using these diagonal lines going across, and I'm decomposing it, or in other words, I'm separating it into triangles. All right. If I want to know the missing angle measure in a polygon, what I need to do is I need to find out how many degrees are going to be in this polygon first, and then I'm going to subtract what I have. So I have 1, 2, 3, 4, 5 sides. I'm going to triangulate this. I have 3 triangles, 180 degrees times 3 with a total of 540 degrees. I'm going to add up these parts here. So if I take 70 plus 120 plus 116 plus 92, I get 398. So I'm just going to take my 540, subtract my 398, and I'm left with 142 degrees for this angle here. All right, the last one's probably the hardest. Each angle measures 135 degrees in a regular polygon. Remember, that means all the degrees are the same. How many sides does a polygon have? Well, here's what I'm going to do. I'm going to take my 135 degrees and say, okay, if I had, let's just kind of guess and check here. If I had 5 angles, 135 times 5, that's 675 degrees. Totally. In a 5-sided shape, we just found out that that was 540 degrees. Do they match? No. We found out a 6-sided shape had 720 degrees on the previous page. So let's see if that works. 135 times 6, that's 810. Does that work? No. If I had a 7-sided shape, remember, each time I add on, I'm just adding 180 degrees. So I'm going to take my 720 and I'm going to add 180 degrees and say, okay, the next shape would have 900 degrees. 135 times 7, 135 times 7 is 945. That is not equal. Okay, so my next shape would have 1080 degrees. And that would be an 8-sided shape. 135 times 8. Does that equal 10,080? 135 times 8. And that does equal 1,080. And so that's my answer. Good luck studying tonight. Have a good night.